But we are ready for our first talk today in track 1. So here to kick things off is
Alex Eagle. Alex is another Angular alumni, and he worked at Bazel, and he will give the rest of the introduction himself, as he told me. So give it for Alex Eagle.
Choice. Love that song. I believe that is the music video for that song, too. They walk up and down stairs, backwards down the stairs. Very cute. Hello, everybody. It's fantastic to be here at the very first Monorepo World. I'm really excited. This is one of the preeminent build system conferences taking place this month here at the Computer History Museum. You can all come back next week for BazelCon. Before I get started, this is Python Monorepo with Bazel. Before I get started, let me just do a quick audience survey here. How many of you are primarily doing JavaScript in a JavaScript repo? Okay. 3/4 maybe. Okay. How many of you are doing some Python? Okay, and how many is in the same repo with the JavaScript? Okay. Like six people. Okay, interesting. Okay, cool. Let me switch over to the slides if I could. I am plugged into both, and my Ethernet cable is now taped, and so everything should go fine. Hopefully it's fine. So yes, my name is Alex. I've been working on Bazel for a long time. I worked at Google with our esteemed keynote presenters, Jeff and Victor, for a long time on the Angular team. Met my co-founder, Greg, working there. We rolled out Bazel to some set of the Angular community, and I know that was a little bit of a challenge, and so a lot of my talk today is to reintroduce you to Bazel if you've already heard of it or tried it. The perception about Bazel is that it's complicated, and I would like to show you that it is not as complicated as you think. You don't need a PhD in build systems in order to get started and use Bazel for your project. So what is Bazel? So this is the build system that Google developed internally. Jeff and Victor and I all used Bazel regularly as we were developing Angular, and so and I think NX borrowed a lot of ideas from Bazel as it was getting started. Still borrowing ideas from Bazel. Thank you, Jeff. Stole. You're not going to give the ideas back, you're saying. You're not borrowing them. OK. Well, we'll take ideas back from you, so it'll be fair. There's a lot of reasons that Bazel is very popular today in Silicon Valley among a lot of the big tech companies, not only because they have ex-Googlers working there, but because it gives you a lot of fantastic properties about your repo. And I know that this is a long list of properties, so I've helpfully given you this acronym that you can remember, IPCR-CUI. So if you just keep that in the back of your mind, that will help you remember incremental, parallel, correct, cached, et cetera. The one I want to zoom in on today, and it's a little bit tying back to what Victor was saying in the keynote about reliability, is that you want your build to be fully reproducible. This is one of the main guarantees that you get from a build system like Bazel. It is very, if you can imagine there's a dial you can turn from 1 to 10, Bazel's really trying to turn that reproducibility dial to 11. So this is a property that you can get by a combination of two things. If there's, one of them is hermeticity, which is the idea that all of the inputs to the build are known and pinned ahead of time. Bazel fetches them for you. Today we're going to be talking about Python, and it fetches the Python interpreter for you. There's nothing about your system, no offense, but we don't trust what's on your computer. We don't want to use anything that's on there already. The second thing is determinism, and if you have determinism, that means if I run the same thing twice, I should get the same result with the same inputs, and so things like timestamps shouldn't show up. And if those two things are true, then I should be able to go back 3 months and take a release that we shipped and make a single cherry pick commit on top, build and push, and there's no behavior changes other than the thing that I cherry picked. I'm not going to get any surprises. Reproducibility is a pretty important guarantee. OK, one of my favorite quotes, the difference between bravery and recklessness is whether the outcome is desirable. Why am I giving you this quote? Well, the rest of my talk today is an extended 20-minute live demo. And so it's either going to be brave or reckless, and we will see which it is. OK? We're going to make a Python monorepo from scratch. I've got an empty terminal window. We're going to be in a temporary directory. There's nothing hidden up my sleeves. Also wearing short sleeves just to prove the point. And what we're going to build is a full-featured Bazel application that shows a bunch of properties. Right? We're going to use Aspect CLI, my company Aspect. We started like 4 years ago. We've been doing a lot of consulting around Bazel. We also have products and services built around Bazel. One of these products is this improved CLI. I'll talk a little bit about other products at the end, but of course, today's talk is mostly about Bazel and things you can do with it. So Aspect CLI is not required to do any of the things I'm going to show you today. You could do these things with vanilla Bazel, just not as nice. OK, you can go see our docs about this, and you can also install it yourself on your laptop. Of course, I've already done that. I'm on a Mac here, and so I've done brew install, and we have Aspect CLI set up and ready to go. So the first thing we're going to do is switch over here to a terminal, and I'm going to go to a new temp directory. I'm going to see how well I can type in front of everyone here, and I'm going to run aspect init. So this is going to be a wizard to prompt us how to create a new project. I'm going to call this thing Monorepo World in honor of the conference that we're at here. So the next thing we see is it offers us a choice of a bunch of languages that we can code in our repo. And Python is only one of 6 here. One of the things about Bazel is that it works with almost every language and framework today. And Google uses it for every single language that they code in. They have started adding more ever since we forced them to add TypeScript way back when. For this talk, of course, we are going to pick only Python, but you're welcome to try running aspect init and see how this works for other languages. Then it's going to ask us a few more questions. So do we want to set up code generation? Yes, we are going to show you how that works. Of course, we're going to want to scaffold out a new library because we're showing you a monorepo. This is going to use Copier, which is a tool from the Python ecosystem to do that. Do we want to set up formatting and linting? Yes, we're going to show you how those things work. We're going to use Rough, which is written in Rust, super fast tooling to do linting and formatting. Do we want to set up version stamping? Yes, I'm going to show you how that works. We are going to make a release. Protocol buffers, that's not today's talk. Let's step quietly out of that room. And then for OCI containers, yes, we're going to build a container so we can push to production. It's confirming my choices, and then it will run a post-scaffolding hook to clean stuff up. That's not really essential, and to save time, I'm going to tell it to skip that. OK, so now we've scaffolded a new project in a directory called Monorepo World, and it gives us some instructions, including, very importantly, there's a README in that folder. We'll look at it just a little bit, but this is one of the most important things you need in a monorepo, especially if you're adopting tools that not everyone is familiar with, is to have a very easy README for everybody else on your team to be able to follow along. So you don't want them to be mad because you tried checking in some Bazel stuff, OK? So I'm going to use Visual Studio Code. Of course, you could use whatever editor you like. And let's open this in the editor and get started. Do I trust myself? I don't know. It depends how much sleep I've had. OK. Hopefully this is big enough for those folks in the back. What we have here is a new repository. It's got a whole bunch of files. We don't really care what they are. We're not going to look through them. What we want to do is start writing some Python code. And so we're going to make a new folder called app. And of course, the convention in Python is to use lots of underscores. Dunder is the abbreviation for when you put 2 of them together. So dunder main.py is the convention for an application that should be runnable. OK, so we're going to build a new application. Let's pretend for the sake of this talk that I don't know Python, which is basically true. And so we're going to go to this getting started page for Python requests. And it's got some code here that I'm just going to literally copy paste into the application. OK, and now what I want to do is run this. And so how do I do that? Well, we want to run it with Bazel because, like I said, we want it to be reproducible. We want it to manage the interpreter for us. And so let's look at the README, because I told you that's where to look. Formatting, linting, installing dev tools, working with Python packages. OK, so we've added a new import statement. We're going to run aspect configure to update build files. So what does that mean? So Bazel uses these files called build. A few other build systems use these as well, like Buck2 and Pants. And that's going to have all the instructions. We don't want developers to have to learn how to do any of that. That's a regression from their current behavior, and that's where PhD becomes involved. So we're just going to open the terminal here in VS Code and run aspect configure. And it's going to give us an error because requests is unknown, right? So I pasted some code from that web page, and requests is not in my project right now. That's easy to fix because we're going to use the standard pyproject.toml. For those of you coming from JavaScript, which was about 3/4 of you, you can think of this being like a packaged JSON file. We'll add requests here as a dependency. And now I'm going to run a pinning operation, repin. OK, so what this is doing while it's running is we're giving ourselves a reproducible set, not only of the Python interpreter, but all the dependencies of our project, including transitive dependencies, right? So we're producing a lock file. If we look in this requirements folder, we see there's a couple of other in files. So we need PyTest, for example. We're going to write tests in a few minutes. All of that comes together in this all.in file, which points to those. And then this is the thing that needs to be constraint solved. It uses a tool called pip compile from a project called UV, also written in Rust because we like things to be fast nowadays. And so its job is to create this file I'm showing right now, requirements.txt. This is, as you can see, certify, for example, comes in via request. This is a transitive, not a direct dependency. And we're getting the cryptographic hashes of that library because we want supply chain security. If somebody grabs a deploy token for that project and pushes some bad artifacts, we don't want to download those and use them in our project. OK, there's a little bit of some Go code compiling here because, of course, Bazel is capable of compiling lots of languages at once. And one of the tools that's being used here is written in Go. Not important, it's all done now. And so this file has been updated, all of our dependencies are available. And so now if we look in the application that we started writing, we now have the build file written for us. There's nothing we need to do. It's got app_bin. And so we should now be able to do Bazel run app bin. And so it's going to print out the result that we got from that README, which was just go fetch some code from the internet. OK, so there you go. Immediate gratification. We've got like a Bazel project up and running, and we've run our program without having to learn any Bazel stuff. So what are we going to do next? So the next thing is that the editor does not look quite the way we want. It's important that there not be any of these red or yellow squigglies. The editor is sad. This is a common misconception that in Bazel you can't make the editor work. The answer in Python is, of course, virtual environments. This is where you would normally start from if you were creating a new project on your machine so that the editor will look around in certain folders and know what to find. And to fix that in our case, let's look at what other stuff is in that package that got created for us. So if we query app:all, we see that there is something here that's a venv. That's a runnable target. If we run that, it will create a standard Python virtual environment for us. And the editor, of course, understands virtual environments, offers to select that for our workspace folder. So if I say yes, now the editor will go find that site packages folder that Python installs. And now request is no longer a squiggly, and all of our auto-completion and jump to definition works. Right? And if I hop in here, we can see I'm in this. It's under a package. It's a folder called site packages. The interpreter lives in there. It's like this is how Python tooling is meant to work. And so the answer, of course, is that Bazel shouldn't be weird, and we shouldn't be teaching the editor any Bazel stuff. Instead, we should be teaching Bazel how to act like every other tool expects. Cool. So that's working. Now let's try watch mode. So JavaScript developers are used to having a great watch mode. Python developers don't always expect that. This is a separate tool. So I'll look in this tools folder briefly and show you. So there's a bunch of tools installed here. I'm not going to talk about any of these other than the fact that Bazel is managing these for us. So if I was to run this version of Docker Compose or this version of Terraform, it is exactly the version that the rest of the people on my project are using. There's nothing for me to do, and it will lazy fetch those on demand if I was to run one of them. For watch mode, iBazel is the tool we need. This is a little wrapper script that tells Bazel what to do. So I do /tools, iBazel, run app_bin. Now we're running it in watch mode. And we go back to the application. Now we should have live editing. So I can say we got, OK, here's where I'm typing in front of everyone. Format this thing. OK, and so we can see as the editor was saving in the background, the application is restarting, and we can see that the string got shows up here. OK, so watch mode is working. That's cool. Now let's install a first-party dependency. We want to be able to copy these and scaffold these out. I'm not going to create one of these from scratch, partly because of time, but also because it's really important to see how this copier thing works. Let's say that there's a new team within our company, and they're obsessed with cows. This is a cattle company. I didn't tell you. And so there's going to be something here to let the cow say what we just found from the internet. I'm just going to go shop around for a repo that provides what I want. In this case, I've created one on GitHub that's just a template for a Python library. Sorry, let me zoom in. So this is assuming that we've run aspect in it, so we just have these tools in this location. And so if I copy this, then it will stamp out a copy of this library in a place called mylib. And then we'll also run this bulldozer command, which is just a way to teach Bazel that that thing now exists. And then there's one more step on this README, which is to go to that all.in file I showed you earlier, because of course this app is going to need a dependency in order for cows to say things. It has its own pyproject.toml file, which has its own dependency, and our job in a monorepo is, of course, for dependencies to all be managed, but still to be constraint solved together so we know that they're compatible. So if I open tools.in, or sorry, if I open all.in and put mylib requirements.txt. Now I just need to do that repin operation again, and I will have that new library is now installed and all the dependencies are available in my project. Cool, so I could build it. Let's actually go over to our application and start using it. So instead of just printing, I'm going to, from mylib, import, and of course my editor is working, import say, and so if I say moo, and then let's run the application again. Now we have an error because there's no module named mylib. Well, the build file wasn't updated, right? It doesn't say that it has that dependency, but of course that's just a matter of telling it to update that by running configure. And now if I run the application, now there's a delightful cow who says what was gotten from the internet makes the application a lot more fun. Everybody likes this more. We've added value, is what I'm saying. We've added value to our enterprise by having a cow say this thing. OK, cool. So that's working. We have a third-party library. Let's see what we want to do next. Now we're going to add a test. So we're going to go into this new cow library. It didn't come with any tests. We're going to just use PyTest, and it's going to work even outside of Bazel because our job is not to make everybody change their behavior. So to add a test, we're going to go to this mylib folder. We're going to make a new file. We're going to call it moo-test.py, and in here we're going to from mylib import say, and then we're going to make a function called test mooing. And of course, to start with, when we're writing tests, we always want to see them fail before we see them pass. So I'm going to assert that say moo test is something wrong, like fail or whatever. OK, now we want to run this test. So of course, we need to update the build file again. Sorry, ran the wrong thing. And then if we look in the build file now, what we should see at the bottom is that we have a py_test. So this is how Bazel expresses test that it's going to run. It's going to manage the version of PyTest and everything else that's going on here. So if we try testing this thing, we should see the right failure. mylib : this. OK, and the failure we got was assert none equals fail. So that's what we expected to happen. Turns out this say function that I called does not actually return anything. And so I can make the test pass by correcting this code. Now, that's interesting, but not sufficient, right? What we really wanted to do was to show that Bazel's not making you break your workflow. And there's going to be developers in this project who don't want to switch to use Bazel. So that's fine. What they want to do, let's look again at the output of query in mylib all. And we'll see that there's a bunch of targets here now, including one that's a virtual end for the test. Right, so we're going to have for every executable thing, programs and tests, we want them to have their own virtual end because they have different sets of dependencies. We want to drop into that virtual environment and know that we're only seeing the dependencies for that thing. So we will run that. Now we get a virtual environment that's specific for the test. Editor offers to boot it up. I say yes. Now what's cool is if I leave this terminal and open a new one, the editor will even hop into that virtual environment in the editor in the context that my terminal is in, right? So I should be able to go to mylib and just do python-m pytest, and the test runs just fine here, OK? So we're not breaking anything. In fact, let's see if we can also debug this test, because debugging is another thing that commonly misconception is impossible to do with Bazel. So since we're in a virtual environment, what I should be able to do is open the testing tab, tell VS Code to configure tests. It wants to know which framework is used. It wants me to pick a folder. Now we'll auto-discover those tests. And let's go back to, sorry, I didn't actually open this new file, say.py. So this is the library code we got. This is where the function is that we've been calling. So if we stick a breakpoint there, we tell it to debug all the tests in this file. Of course, we hit the breakpoint. You know, the debugger is working like we expect. There's our string test that we had passed in here. And if we tell the debugger to continue, then the test is working here too. So all of our normal developer workflows continue to work. OK, cool. Let's now step to how do we run tools. So if you've read, there's a lot of great books about how to do monorepos and how to do development in a large organization. And one of the things they say is that you should not force teams to use standard tools, right? But we just said, oh, well, like Bazel's going to manage your monorepo. Maybe NX manages your monorepo. You want teams to have the ability to pick and choose what tools that thing is going to run. And of course, it's not opinionated about which tools you use, right? It can run any tools. And in Bazel, there's a misconception that you have to write something called custom rules and get into Bazel's extension language in order to use any tools. That's false. Let me show you. So we're going to use Jinja 2, which is a templating engine that's pretty popular for Python projects. So that's just a couple of steps. The first one is, of course, we need to download the tool. So this is where we're going to go to this tools.in file, and we're just going to say, hey, I would like to be able to run jinja2-CLI. That's the package that they ship. Then I'm going to leave this debug console and go back to a regular terminal. We can deactivate this virtual environment. We don't need it right now. And then we'll do tools repin one more time. This is now going to fetch the Jinja2 CLI and all of its dependencies. Now we just need to be able to run it. And instead of having to write any custom Bazel stuff, what we're going to do is go in this tools folder and find this build file. Sorry, that's not the right one. Tools/build. OK, so we see copier is already here. This is what I used earlier to stamp out that mylib. So we're just going to put one next to it. And this is a console script is what people in Python land call a package that ships binaries you can run. This is similar to the bin field in a package JSON file. So this is called Jinja2. And the package it comes from is Jinja2 _CLI. Now we should be able to run it. Tools Jinja2. And what we see when we run it is, of course, it just prints its help, because we didn't give it the arguments it expects. That's actually kind of great, because the help that you get from the CLI is exactly what you need if you want to now use this tool as a build step inside of Bazel to transform some inputs into some outputs. So we'll go back to the build file for the library. There was a second function I did not say anything about, right, which is down here. We're going to do moo_stamped. It wants to read a header file. We need to fill that header file in. And so that's where the templating engine is going to be useful. The template for the header file looks like this. It says built at timestamp, so somebody's job is to fill in that timestamp. I'm a cow. I found this on the internet. We're really into cattle at this company. So we look up here in the build file, and there is a section called run_binary. So this is a little adapter to take anything that's buildable and say I want to use that to generate some, take these sources. So there's some data in a JSON format. There's that header as a template. And then I'm going to pass these arguments, right? And -- format here is the same as -- format down here. We're just filling in the CLI arguments for this tool. The tool here, like we said, is tools::Jinja2. So now we should be able to build this thing. So this is mylib : make header. OK, so interesting. I get an error. What's this error about? Visibility. So if you have a big monorepo, I'm sure you've encountered the problem that you have a spaghetti of dependencies where some application that's mission critical took a dependency on a library that nobody's maintaining, and oops, the library maintainers were not expecting to provide that kind of quality SLA for that application. So there's a visibility system to constrain this. And so there's an opt-in where I need some code to be visible to me. Fortunately, the Aspect CLI includes some plugins. One of them auto-repairs this kind of error. So if I say yes, it will fix it, and I can just try again. OK, so we've built our header file. We can take a look at what's in there. And it says unstamped. We'll see in a minute why that's important. We want determinism, right? I said we want things to be reproducible. We want to get cache hits. So if this was to change all the time and have a timestamp in it, that would be no good. That's why we've chosen in this build file to put the word unstamped here. OK, cool. So we've run a tool that we fetched from the internet. What do we want to do next? And we've done the code generation on it as a build step. So next we want to be able to depend on that code gen. So that's a simple matter of updating our app. And we're going to, so we see that there's this moo_stamped. So we're going to use that from the main once I find it. So instead of moo, we're going to do moo_stamped. That's going to use our header file. And now when we run the program, of course, the first thing we get is, oh, we forgot to update a build file. In this case, it says that we didn't declare this dependency. Now, in this case, the dependency is hard for this generator to see, because it's not an import statement. And so we're going to declare it manually in this case. It still doesn't need a PhD, because all I need here is header.txt to be a data dependency, which means it's a runtime dependency of this library. Gets propagated to any application that transitively depends on this library. And now our cow has this little header at the top, built it unstamped. I'm a cow, found this on the internet. Cool, so we've wired code generation into our application. Still nothing too difficult here. So, and we saw what happens with visibility. I have just a couple minutes left. I want to show you 3 more things. One of them is formatting. So formatting is kind of a solved problem. You know, everybody in JavaScript agrees you just run prettier, you don't think about it. We certainly don't want to spend time in code review discussing whether single quotes or double quotes are the right kind of quotes in this given situation. So if I go back to my main, and let's say that I violate the style guide of my team and I put single quotes here, am I going to end up in an infinite code review cycle with somebody who disagrees? Well, of course, we've got a pre-commit setup in this repo, which says you can do aspect run this thing. I'm going to do a simple version of that, which is Bazel run format. Okay, let me make sure I still get that file up because it happens so fast. So if we watch what happens here to line 6, when I run the format, it's going to, first of all, expect to ask Git what files are meant to be part of the project. So if I do a git init, that will cause this to be found by Git. Now it's running formatters for every language. It so happens I only picked Python. If I had more languages here, it would format all of them. Formatted Starlark code too. That's the language Bazel uses for its extensions, including the build files. And now you can see all of our quotes got fixed. Okay, so formatting, solved problem, run it as a pre-commit hook, stop talking about it. And now linting, we're going to want to find problems in our code. And of course, linters are something we expect to be wired up with our build system. And for this, let's say I leave off one of these close quotes and I make an unused import of import OS. And now I want to lint this thing. So what am I going to do? I can do Bazel lint. Technically, Bazel itself doesn't have this command. It comes from the aspect CLI. I could run it either way, but I'll do aspect lint. And let's say app:all in this case. So I'm going to lint every Python, any library in any language beneath that folder. Let me make the terminal big. So here's what we see happened. There were a couple of problems found. The first is this formatting issue, right? So I can click right here to go to this line. The other one is that the unused import has an automated fix, right? So it's offering interactively to apply my automated fixes. I can say show diff to see what the fix is that it's about to do. It's going to delete my unused import. That sounds great. I'll say yes. And then I will also click on this line that it pointed to where it says, of course, the line just moved by 1 because I removed an import. Fix this, and now, of course, the linting should pass and say everything is great. And if you take a look at the rest of the Aspect platform, we have nice ways of wiring linting into your code review, which I encourage you to check out. Finally, and I'm a tad over time, sorry, is we're going to build a container. And we're going to want to stamp that container so that if it starts crash looping in our Kubernetes setup, we can tell with our monitoring tool that it was this new version of the application that broke it. OK, so this is much easier than you might think. In our main, I'm just going to put a hint here that says OCI:build. So I'm going to build an OCI image, and if I run aspect configure again, it will read this from the source file, and it will know what to do in the build file. This is not built into Aspect CLI. There's actually a little plugin that lives in this repo that told it to do that. Now I get something that's called py3_image, and now I can Bazel run app:image dot load. I'm going to load this directly into my container daemon. I'm also going to add -- stamp because I want to fill in that unstamped variable. So when I run this, it's going to do some fetches because Bazel had been lazy and hadn't fetched these things before. It's building layers. It's putting the interpreter in a separate layer from the dependencies, in a separate layer from the application code, so that as I'm doing typical Docker development task, I have very small layer uploads. It says it loaded the image, and so I'm using Podman here. It so happens you could use Docker. I will do run app. And if the demo is successful, what we will see is built at timestamp, we are now running this application inside of a container. It's ready to ship to production. Our job is basically done. OK. So that's the big applause line because the demo has succeeded. I think I was brave and not reckless. Don't worry, you can still clap at the end. OK, thank you. So last thing I promised in the abstract, but we don't have time for, is to talk about CI. It so happens that Bazel and CI go together great because you can just tell your CI to Bazel test everything all the time. And Bazel's job, sort of like Victor talked about, let the tool do the work instead of the CI do the work. So you can just do that yourself. You can just do Bazel test ... in your Jenkins, whatever you're using. If you want to have that be super fast, you can take a look at Aspect's product. We have something we call Aspect Workflows, which gives you this really great performance benefits of Bazel that they advertise if you go look at the Bazel homepage. It also reduces compute costs quite a bit because we've done a lot of the effort to make it do the minimal amount of rework and rebuilds. And of course, it runs on cloud. It runs on your cloud and not our cloud, so we don't charge for usage. So that's all I have time for. Thank you very much for listening. Please come find me or my co-founder Greg around the conference. We would love to tell you more about why Bazel is less crazy than you thought. Thanks.